Of course, when dealing with these kinds of problems, there's no guarantee that the denominator is going to factor nicely. In particular, thinking back to things we did in chapter 3, we could see that once you get above degree 4, it's really hard to describe factors. And even when you can describe factors, you still have things like x squared plus 1, where we don't like dealing with imaginary numbers for these sorts of things, because those just cause whole piles of other problems. So when we have things of irreducible nature in the denominator, something like a unfactorable quadratic, then we need to put the next best thing in the numerator, where the next best thing is something of degree 1, because you have degree 2 in the bottom. So if we have ax squared plus bx plus c on the bottom, that means we have an ax plus b on top. For example, if we had something like x squared over x squared plus 4 times x minus 1, our setup would mean having to get an ax plus b over that x squared plus 4 plus some other constant c over x minus 1. And then from there, we would solve this in the same way we did previously. We'd multiply over the bottom. We'd be left with ax plus b times x minus 1, x squared plus 4 times c. And then from there, the algebra would devolve into a 3x3 system, 3 unknowns, 3 equations, and you have to do a whole lot more finagling in terms of how you solve that. It might not be quite so nice to just plug and chug to get a value. In particular for c, there isn't a number you can just plug in there to get what c is, but ultimately, it's not really a different process. It's just a bit clunkier, a bit more details. So you've got a lot this week. I don't feel it's really necessary to get into that here. But I do want to at least say that when we're dealing with these types of things, if we have any higher degree factor that doesn't break apart nicely, we just need to be very generic in terms of what goes on top of it. Get the next best thing one step up in terms of the most possible terms it can have. So if we had something like a degree 4 irreducible thing on the bottom, then we'd need an ax cubed, a bx squared, a cx, and a d on the top, and it would still follow the same ideas. It's just, man, that would not be a fun system to work with. Anyway, that's about all we have for this week. Next week, we're going to keep moving here and keep working on in the chapter to talk about what happens when we're not just dealing with linear things. So we're going to talk about systems and how we can handle them for when we have curvier equations.